Alright guys, just want to show you this. White wire is coming from my secret sauce. These wires over here are nothing, just experiments. We go to 2 coils, 20 LEDs, to a capacitor. I'm trying to see here what is, this is a positive, negative, positive, negative. To the positive end, negative. Well, the stripe is on this side. There it is. Coming around, making a loop. You can see I got the capacitor on there, and it's charged over 300 volts right now. It would be around 330, but I keep blowing out these LEDs here. You can see how this one is much brighter. This one's about to blow out too. I do have 16 volts applied right now, which normally 6 volts would be more than enough to just light those 20 LEDs in my system. But I want to see how high I could charge the capacitor at 16 volts. So you can see I'm over 300 volts there. Like I said, it would be higher if I replaced these 2 dead LEDs now. This one, just 2 diodes, Afro plug. This one's about to blow out too. This is just a ground going to a plate. Yeah, it's pretty active no matter where I put that sucker. Up, 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 up. Wow. Wow, up, up. Yeah, I'm about 10 inches away from that coil. That's where the most activity is coming from. I know I say that coil is very active, but yet in electronics you learn that an inductor and a capacitor are called passive components. But I say this is highly active because it has this constant expanding and contracting electromagnetic field that is pulsing, you know, over 1,000,000 times a second. So anyhow, I've tried many different varistors in here, in between here and the LEDs. 5 different types of values. It's not working for me. I was hoping it would help control the brightness here. I believe if I remove this diode now, I'm going to experiment with turning it around and many other experiments, but just wanted to show you that today, guys. You know, what's interesting here is that this LED is much brighter than the brightest LED here. You know, and it's not even making contact. Kind of funny. Our voltage is dropping now. I just blew out another LED. That one right there. That one's still working. That one's out. That one's out. This one's out. These are on. That one's on. That one's going to be blowing out soon. So like I've said in the past, guys, I said even if you don't figure this is over Unity or something like that, I said it's $1 million invention. I said There you go. How many Christmas trees and Christmas lights? You could have LEDs blow out and the other ones still keep working. That one appears to be lit, but it's not. It's a reflection of the light of the one next to it. I usually put some black marker on there like I did these two so I know which one to replace. I'm replacing quite a few lately with these experiments. Yeah, voltage is still dropping though. It would be about 330, I believe, if all three of those LEDs were working, but yeah, I gotta figure out something about that. Usually what I would do is run a wire from here. Well, there's a green wire right there. This end is not connected. Or no, well, that is connected. But if I add a wire from here back to there without the capacitor or whatever, then the energy would be even across all those instead of all the energy. Instead of a lot more current on the first LED or last one or whatever you want to call it. Yeah, I am at 16 volts right now. I mean, that's why. I mean, we don't have a million LEDs on there. Hey guys, so I just had to put this on film. 30, 40, 50 LEDs lit. Where's my finger? With power off. Now in my last video I showed you guys 20 LEDs, and depending on where I tapped it and measured it, I was able to get as much as 60 volts. It's all off right now. Forgive me, this is all I can show you right now. But there's 50. I only get about 1 volt each LED right now, so I'm only getting about 50 volts across these 50 LEDs. So it's kind of strange, but they are still lit up, I believe, just as bright as the 20 LEDs were in my last video. So anyhow, just wanted to put that out there. Alright, so let's do a little experiment here. This is my active coil, and by active I mean the field is expanding, collapsing 2 million times a second. This blue wire, that's just going to 2 diodes, like an Afromenko plug, capacitor, 20 LEDs, ground wire, no big deal. But right now, and this is another way, you could pick up the energy that way, you could pick up the energy with another coil too. So let's see, we just have 2 very nicely bright lit LEDs on here right now. Now I'm expecting that even if this is a pulsed DC, that this coil should be AC. And I just did an experiment too, where I just turned around both of these LEDs the other direction, and it still worked. Okay, so right now, let's see if I'm going to stick a string of 10 on there, see if that works or not. Now when I do that, I'm sure I will have to readjust the frequency on my frequency generator and adjust the distance between these 2 coils. Yeah, which is interesting that there's and I've seen a few people, different experiments with that. There's a specific best distance between transmitter and receiver. Let me put 10 in there and see what happens. Okay, it is not lighting up 10. Alright, now let's do one or two more experiments here. The distance of these coils is affecting the brightness of these lights. Even though I added those, even though they're not on, the distance in there is changed a little bit. Alright, since this is a C, okay, let's, well, I just made this up. Let's put a full wave bridge rectifier in there and see what happens. We know we can light 2 LEDs this way, but you know, if we only light 2 LEDs, we're only using half of the energy, right? So we will definitely want to use the other half of that energy. Otherwise it's wasted. So we'll be right back. Okay, so now, bigger distance, full wave bridge rectifier. Now we're lighting 10. And maybe we could still add some more on there. Now notice I got a bigger gap. If I close that gap, leave a little gap like we had before, you see these are out, these are on, but we'll have to retune. And oh, that's about it right there. Not nearly as bright. Let's move it even farther of a gap. Let's see what happens there. Oh, now they're both out. Now, let's see. Oh, yeah, no good. So there is a very specific distance. I'm adjusting the frequency right now. That's pretty close. I can get a little better if I fine tune. But just wanted to show you that, guys. Now, well, let's go a step farther. Let's see if we could add, do I go in series or parallel? We might have to try both. Let's see. So I'm really curious now if we're going to be able to pick up more energy this way than we do this way. Yeah, because that has no coil. This has another coil to coil. You still got the full bridge and half bridge. Okay, I'll be right back. Okay, we're back. Now you see these 20 are not lit. There's our full wave bridge rectifier. There's our active coil and the pickup coil. Okay, but now watch this. This is a ground just to a plate ground, a small plate, not to earth ground. And I'm going to connect this in the middle. And there you go. So now, what now? These did get a little dimmer. Let's see. Yeah, it's hard to see. But they're pretty bright. So we got more than 2 LEDs on there now, don't we? So it's just one of the many ways to feed off of this energy. I just haven't done it this way yet, and I'm going to be doing more experiments with coils. I never forget Don Smith and his later designs had 3 fixed coils. 1, 2, and 3. Now, maybe somebody knows out there what those 3 were. I don't know. I haven't watched all his videos in great detail and studied him over years, but I keep asking myself, why not 2 coils? Why not 4 coils? Why 3. What is he doing with those 3? Is it known, common knowledge out there, or is it only theorized? Does anybody have any idea why he used 3 coils? Let me know in the comments below if you do know. One idea comes to me is like if he's maybe, and I don't know, but something popped in my head the other day that maybe he's got negative on one coil and positive on the other coil, and the third coil is picking up the other 2. So now my next thought is, how many more can I add on? And they're all in series right now. And is it better to have them in series or parallel? So I'm going to do a bunch of experiments on that right now. And hopefully we'll be back, but it is getting late right now. So, alright guys. Okay. These are lit. These are lit. 50. And we got 30 lit off of this other pickup coil here. There's a very small space between them. That's where it seems best. Again, here's only 8 volts, 2.050 megahertz. Let's see if I could show you this. I'm going to bring this frequency down. Alright, now let me show you this here. Now I'm at 1.910 megahertz. We're going to go up, 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 up. Oh, oh, I should have been out here. Okay, these are just suddenly lighting up. And these are lighting up. These are not quite as bright yet. We're at 2.020 megahertz. Let's go up. Getting brighter, brighter, brighter. That's about it. They're all about equal right now. Now you notice I got my ground here, my plate ground, just connected to the middle of these LEDs. Okay, that's where it's best with this particular setup. Okay, it's getting later. Let's see, I'm back. Okay, now we have, these are lit up. These are all very well lit up. Let's see, off our bridge rectifier we have 10, 20, 30, 40 LEDs now. What I'm seeing is, well, that space is very small there. As I'm adding more on here, the closer I'm going to have to bring those coils. So at this point, there's no reason to go to 50. You can't get the coils any closer together. Maybe a hair. But at this point, next thing I want to do is try the LEDs all in parallel. Okay, well, this is very interesting. Let's see, we got our 50 here off of that coil, our 20 off the 2 diodes Aframenko plug, and we got our other coil here to our full bridge rectifier, going down to only 20 LEDs right now. This is an earth ground, that's nothing, that's not connected. So only 20 right now, but now let's see, we're still at only 8 volts, 1.970, and I'm going to start going up, 980, 990. Alright, now I want you to watch. Now you see these being lit up right away. Let's see, these are also lighting up. Now, these are pretty dang bright. Those are pretty good too. There we go. Now these are starting to come on. Up, up, up. That's about it right there. That's about the brightest spot. Okay, now they're all, well, these are still a little brighter. These are about equal to those. Now let's see, we're at 2.090 megahertz now. Now let's continue going up. Now these are getting dimmer, these are getting dimmer, these are still extremely bright. Now these are starting to get brighter again. We're going up, 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 up. Oh, right about there. That's it. Now, that's what I find interesting, because now we're at the second, like I told you, the second resonance frequency. And now these are not lit, but these are lit, and these are still very bright. So that's interesting. So it's kind of showing me the difference between the way a pickup coil will work and an Avraменko plug will work. Okay. These two coils are about that distance apart. Now we have 30 on there. They're very bright. They're brighter than those. Those are a little brighter than those. Now we're at 2.080 megahertz. Now we're gonna go up in frequency. Let's see, maybe I could use this video myself as a reference. 2.090, 2.1, up, 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 up. These are dimming out. Those are getting a little dimmer. Okay, these and these are out completely. These are still very bright, which is very interesting. Let's keep going up, 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 up. Now we're at that second, right there, resonant frequency. These are out. These are still very bright. Alright, now we're at 2.3 megahertz. Interesting. Very, very interesting. What is that telling us? Now, let's go back down. Down to there. Right, these are definitely brighter. Okay. A little bit farther here. Let's see, what are we at? The higher frequency, lower frequency. Right? Yeah, let's see. If I go up the higher, let's go out, then we just have those two, right, groups. If I go to the lower one, we get all three groups. Now, these seem to be, I added 10 more. They're kind of stealing this one's thunder over here. I'm not sure yet. There's 50, but these are really bright, and it keeps making me wonder, can I go 50, 60, 70, 80, 90, 100 and still have them brighter than these? Even if these go out, there'll be more LEDs over here than over there. Okay, one more quick thing. Alright, now we're at, actually we're at 8 volts. This was not as bright as this. Now if I increase the applied voltage from 8 volts to 9 volts, there you go. Now they're almost as bright as these. There's 10. Now they're as bright. Now they're all pretty equal. But what's interesting is if I go down to 9 volts, 8 volts, 7 volts, 6 volts, I'm like, these are still pretty bright. So like I said, might be able to put more here than you can over there. Which really makes me think. Alright, real quick, one more thing. Let's see, I just went down to 5 volts now. And you can still see those are pretty darn bright. Those are almost out. I think those are out completely. Those are lit a little bit. But only 5 volts. Like I said, that makes you think.